Section 8.7 is doing our algebra with sign numbers. We don't change anything we've been doing. The only addition to anything we're doing here is got our sign numbers in it. So we're going to work with the side with the variable. We're going to do the opposite of the operation, which in this particular problem it is plus, so we're going to do minus. We're going to do it to both sides of the balance equation. So plus 25 minus 25 goes away. We didn't do anything with this, so we drop it down. And here we have a plus 4 and a minus 25. So we take the smaller one from the bigger one and keep the bigger one sign. So that'll give us minus 21. 4 from 25 is 21, minus drops. Then we're going to do the same thing we've always done, is we're going to divide, since this is multiply, we're going to do the opposite, remember, by the number in front of the variable. So we're going to divide by negative 3, because that's the number in front of the variable, negative 3. So how many negative 3s and negative 3? 1, because everything's going to cancel, just like it has before. 3s and 21 is 7. And how many signs? 2, so that's going to be positive. So again, we're not doing anything different operationally than we've done before, we're just doing it with a sign number. So over on this example, which is problem number 2, we're going to take away minus 11 from both sides, correct? Because this is plus 11, minus 11 cancels it out, nothing here, we're going to drop it down. Minus 9, minus 11, signs are the same, so we're going to add them up and keep the sign, correct? Okay. Again, we have a multiplication sign, so we're going to divide by the number in front of the variable, which in this case it's minus 4. Cancel, cancel. Y, 4s and 25, 2 signs, positive. Okay, let's do another one here. We have minus 11 is our first thing we look for. We're going to do plus 11, plus 11. Remember, I always said you need to write down that operation sign when we did problems. It's really critical when we're doing our sign problems here in this chapter because we don't want to lose a sign. So minus 11 plus 11 is canceled. We're left with 0. 2a drops down. 3 plus 11 is 14. We don't have any negatives anymore. Still going to divide by the number in front of the variable. And we have all positive, so our answer is positive. I did this one just because they shifted it around, flipped it over, so we have the variable to work with on the right side instead of the left side, but again, it's no different. So we're going to do the opposite of minus 10 is going to be plus 10. Plus 10. Again, we should write down our operations. Cancel. We owe 30, we pay back 10, we still owe 20, or the smaller one from the bigger one, keep the bigger one sign. Didn't do anything with this, drop it down. Now we're going to divide by the number in front of the variable, correct? It's going to divide by minus 5. Cancel, cancel. X equals 5s and 20 is 4. 2 minuses is a plus. Okay? Wanted to do one challenge problem with you, just because you're going to see it in your next math course as you move up through the math courses, 60 and 65 and 95 and so on, is you're going to see the problems with variables on both sides. Over here, we just had variables on one side. Now we have variables on both sides, so it's just one additional step. So we still need to get the answer x equals whatever. So we need to get all the variables on one side and all the whole numbers on the other. So we just have an extra step. So let's go ahead and put the variables on this side. So it means I have to get rid of the minus 9. We do that by doing its inverse, as we always have. We're going to plus 9 to both sides. Well, this cancels then. So then we have 8x is equal to 3x, because I didn't do anything with that. Plus 15. Signs are the same, we add them up. Well, now we need to move the x over here. And so we're going to take away 3x from both sides. That essentially moves the x away because it's going to cancel each other out. So positive 3x, take away 3x is 0. 8x minus 3x is 5x. And then we drop the 15 down. So that's that extra step in there by moving the variable onto the other side or canceling it out. These are balanced equations. They're the same on both sides. So as long as we do it mathematically, if we take away 3x from this side, we have to take away 3x from the other side because it's balanced. That's why the equals are there. And then our final step then, we're going to divide by the number in front of the variable, which in this case is 5, and x is going to be equal 3. And of course, we can plug it back into our answer on both sides of the equation. So 3 times 8 is 24, take away 9 is 15. 3 times 3 is 9 plus 6 is equal to 15, and by George, it all works. So you may see some of those with just variables on both sides. They're not any harder particularly, they're just one more step. So good luck with the final homework on this. I've enjoyed having you in class, and we'll talk some more.